Hey guys, this is Coach Brian with your 2.3 pre-calculus notes. 2.3 is all about the remainder theorem and the factor theorem. So for our warm-up today, it says use synthetic division to divide. So remember, anytime we have a linear divisor with a coefficient of 1, then we can use synthetic division. So the way we use synthetic division is we're dividing by x minus 3, so what we have to do is we have to change that sign, and then we take all of our coefficients with their signs. So we have a 1, we have a negative 2, we have a negative 4, and we have a positive 5. Excuse me. And so what we want to do is we want to drop that first coefficient, and then we multiply it by the divisor, and we just keep following that process of multiply, add, multiply, add, multiply, add. So 3 times 1 is positive 3, and negative 2 plus 3 is 1. So 3 times 1 is positive 3, and negative 4 plus 3 is negative 1, and then 3 times negative 1 is negative 3, and 5 minus 3, or plus negative 3, leaves us with 2. And that last digit is always going to be our remainder if there is one. And so the way we would write this is we would find our highest degree, which is x to the third, and our answer will start with 1 less than that. So it's going to be 1 x to the second plus 1x minus 1, and the remainder is 2. And you could also write that without the ones. Not a big deal. But we have 2 left over. We have a remainder of 2. And the way we would write that out is we would say x squared plus x minus 1 plus, because it's positive, 2 over x minus 3. That would be our full total answer right there. Okay, that would be our full total answer. Now, thinking about this concept of division and factors and quotients and all this stuff, let's think about the numbers 15 and 3. 15 divided by 3 is an even 5. Like if you wrote it out like this, your answer would be 5. And 3 times 5 is 15. So do we have a remainder? No, we don't. The remainder is 0. And so we would ask, is 3 a factor of 15? And this is, you got to know the definition of a factor. You multiply a factor by another factor, you get a product, okay? Is 3 a factor of 15? And yes, it absolutely is. But what about 15 and 4? If you divided 15 by 4, all right, you get 3 up top, and that will leave me 3. So I'm already having to put in some decimals here and do some different division, okay? So I get to this point where I'm at 3.75, okay? 3.75. I could finish working that out, but I ran out of room. So we get 3.75, 3 3/4, not a whole number. And so what's the remainder? Well, we would say it goes into it 3 times with a remainder of 3 over 4, which is where we got our 3.75. So the remainder is that 3/4 that's left over, that 3/4 that's left over. Since there is a remainder, no, 4 isn't a factor of 15. So what does this all mean? We have this theorem called the factor theorem, and it states that when you're dividing, if the remainder is 0, okay, if the remainder is 0, then there is a factor, okay? That's just the basic. There is a factor if you divide and the remainder is 0. This is known as the factor theorem. factor theorem. So it says, was the warm-up an example of a factor? So if we go back and look at our warm-up, you'll see we had a remainder of 2. So since there was a remainder, then no, it wasn't a factor. Now, we're going to use this same function from the warm-up right here, x to the third minus 2x squared minus 4x plus 5, and it says find f3. So remember, that is our input, okay? The 3 is our input, which means everywhere there's an x, we're going to replace it with a 3. And it's really important here that you follow proper order of operations. So first off, we have 3 cubed, which is 27. And then we have negative 2 times 3 squared, which is 9, minus 4 times 3, which is 12, plus 5. And so I've got this chain of 27 minus 18 minus 12 plus 5. And if you work all that out, it will give you 2. The answer to f of 3 is 2. And we're making some connections here because if we look back, it says, what was the remainder when f of x, the original function, was divided by x minus 3? So if we go up to our warm-up, we had f of x, we divided it by x minus 3. What did we get as our remainder? 2. So when we plugged in a 3, we got out a 2. When we divided by 3, we got out a 2. So the remainder is 2. It's not 0, okay? So we can conclude that x minus 3 is not a factor. Since we had a remainder, when we divided by this value, it's not a factor. And so we have the remainder theorem, okay? The remainder theorem. We had the factor theorem, we have the remainder theorem. So let's try to break this down and see what it means, why it's important to understand this. It says if a polynomial f of x, so first of all, it's a function and it's a polynomial. If it's divided by x minus c, okay, which can be any variable and any constant, okay, any variable and any constant can go there, then the remainder is f of c. So that can be a little confusing. Let's say we're dividing by x minus 7. All right, we divided something by x minus 7. The remainder should equal f with a 7 as my input, okay? If we divided by x minus 5, the remainder should equal f 5. Okay, so we're gonna test this in a few examples and see if this is true. So find the remainder when 3 times x to the fourth minus 8 times x squared plus 11x plus 1 is divided by x plus 2. Tells us to find the remainder. So instead of using division, let's test the theorem we just tried. If it's divided by x plus 2, the remainder will equal f to the negative 2. Okay, and notice those signs are always changing right there. The signs are always going to be opposite, so make sure you're keeping up with that. But what this is saying is I should be able to plug in a negative 2 everywhere there's an x, and it should match my remainder. So let's try that out. 3 times negative 2 to the fourth minus 8 times negative 2 squared plus 11 times negative 2 plus 1. So when I work all this out, I've got negative 2 to the fourth. Negative 2 to the fourth. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 3 times 16. Negative 2 squared is 4, times negative 8 is negative 32. 11 times negative 2 is going to give me minus 22, and then plus 1. So I've got 3 times 16 minus 32 minus 22 plus 1. So working that out again, 3 times 16 is 48. I'm subtracting 54, and then I'm adding 1. If you're wondering where'd the 54 come from, it's the negative 32 and the negative 22. So 48 minus 54 is negative 6, plus 1 is negative 5. So my input of negative 2 gave me an output of negative 5. And based on the theorem we just learned, the output will be my remainder if I were to divide by x plus 2. Since I had an answer other than 0, it is not a factor because there is a remainder of negative 5. Why is that? It's because it's not 0. If it was a remainder of 0, then we could say, yeah, that's a factor. Now we're going to do the same thing again. Find the remainder when it's divided by x minus 3. So remember, the remainder should equal f3. X minus 3, that's like saying x minus positive 3. So we put in a positive 3. And we want to see what we get out. So every x we're going to replace with a positive 3. So we've got 3 cubed minus 4 times 3 squared plus 2 times 3 plus 6. Or excuse me, sorry, plus 3. All right, so we worked that out. 3 cubed is 27. Minus 4 times 9, so I'm taking away 56. No, excuse me, I'm sorry. 36. I'm not mathing very well right now. 3 squared is 9. Negative 4 times 9 is negative 36. And then I'm going to add 2 times 3, which is 6. And then I'm going to add 3. So when I put all my positives and negatives together here, what I end up with is 36 minus 36, which is 0. So is x minus 3 a factor? Yes, it is, because there's a remainder of 0. Proving our theorem, the remainder theorem and the factor theorem. All right, so just a reminder here, some helpful exponent rules. When you're inputting a negative number and it's to an even power, it's going to end up being positive. When you have a negative number and you're raising it to an odd power, it's going to stay negative, okay? It's going to stay negative. Your output will stay negative. So, negative 1 to an even power is 1. Negative 1 to an odd power, negative 1. Negative 1 to the 79th power is going to be negative 1. Negative 1 to the 24th power is going to be positive. Why? Because 24 is even, 79 is odd. So even and odd powers when you're inputting a negative number. It can be a little confusing. So if you remember that even and odd rule, it helps. All right, so now we have got this gigantic polynomial, x to the 79th power plus 3 times x to the 24th power plus 5. All right, plus 5. Now, where do we even begin with this? Where do we even begin? Well, let's look at the coefficients. Or excuse me, we're dividing by positive 1. So that means instead of doing division right now, I could use my remainder theorem and say that this value divided by x plus 1. Whatever the remainder is, remainder will equal f to the negative 1, okay, using our remainder theorem. So if I plugged a negative 1 into all these, I would get negative 1 to the 79th power. That's odd, so negative 1. Plus 3 times 1 to the 24th. That's even, so it's going to be positive. Plus 5. So even though this looked very complex, if I plug in what I'm dividing by, I get negative 1 plus 3 plus 5, which is 7. I get an answer of 7. And so I can quickly tell that this is not a factor because there is a remainder other than 0, okay? If my input does not yield a 0, it's not a factor. So we have some more here. Determine if g of x is a factor of f of x. So pretty much what we're looking at here is still that remainder theorem. If I plug my divisor in and I get anything other than 0 as my output, it's not a factor. So g of x, factor of f of x. So pretty much what we're saying is f of x over g of x over x plus 2. Now, you could divide this out, or you can use that remainder theorem and say that f of negative 2 will give me my remainder. And if I put in negative 2 to the 5th plus 30, all right, I have a negative number here to an odd power. Negative number to an odd power. So 2 times 2 is 4. Cubed is 8. To the 4th is 16. And 2 to the 5th is going to give me negative 64. When I add in, oh, excuse me. I think I doubled that again. Should have been 32. My fault. It might help if I wrote it out myself. Negative 2. Negative 2 times negative 2 times negative 2 times negative 2 times negative 2. You don't have to do that, but I clearly just made a mistake. So that'd be 4, negative 8, 16, negative 32. So we have negative 32 plus 30, and that leaves me with negative 2. And so no, this is not a factor because I had a remainder other than 0. Now on B, same thing, it says determine if g of x is a factor of f of x. So it would be like taking this and dividing it by that. And you could divide it out, or you could use the remainder theorem. And we can say that f of negative 1 remainder will tell us if this is a factor or not. So if I plugged in a negative 1 everywhere that there is an x, negative 1 to the 6th minus 16. All right, so what I've got here is a negative 1 to an odd power. Negative 1 to an odd power, so that's going to give me negative 2 times negative 1. And then I've got a negative 1 to an even power, plus 14 times 1. And then I've just got a minus 16 here at the end. So negative 2 times negative 1 is 2. Plus 14 is 16. Minus 16 equals 0. I have a remainder of 0, which means yes, x plus 1 is a factor of function f. All right, 2 quick examples left. It says find a polynomial of degree 5. What does that mean? It means 5 powers of x, okay? And then it has 1, 2, 3, and negative 5 as its zeros. Leave in factored form. So when I have things as zeros, that's where it's going to be like, x equals 1, x equals 2, x equals 3, x equals -5. That's when there's zeros, okay? I need to convert every one of those to a factored form. So if I have x equals 1, as a factor, that would be x minus 1 equals 0. That would be my factor right there. X equals 2 would become x minus 2 equals 0. That's my factored form. And so you can see what I'm doing here is I'm just changing the signs. So x equals 3 is going to become x minus 3, and x equals -5 will become x plus 5. So just from that, I've got these four, excuse me, I've got these four factors, and if I write them out in factored form, I've got x minus 1, x minus 2, x minus 3, and x plus 5. Now, that's four factors, but my question specifically said I need a degree of 5. So what I can do in this situation to get that fifth power is I can pick any one of these and square it. So I'm just going to square the first one right here, and that alone, like squaring that, and then I'll FOIL it out, and then I'll double distribute all of these things together, would give me something that works. It's not asking me to find a specific answer yet. So you're like, what if this one was squared? Well, that's okay if it's the only one that's squared. And you might say, well, what if this one's squared? That's okay. What if this one's squared? That's okay. You just have to pick one in this situation because it's asking me to find the equation of a polynomial, not a specific one, but a polynomial. So squaring any one of those could work as long as I also included these four zeros. Sorry, I apparently cannot write today. All right, last question. It says find the equation of a polynomial. So it can be anyone. It doesn't have to be specific. A polynomial, degree 3. So its highest degree will be x to the third. It has roots at -2 and 0. -2 and 0. Excuse me. So leaving it in factored form again and not multiplying it, we would either, because it's a polynomial, we could either write y equals, and we could have x squared times x plus 2, or we could have x times x plus 2 squared. And if you're wondering where I got those, it's back to these roots, okay? We have x equals -2, and we have x equals 0. So whenever x equals -2, we can turn that back into a factor, and it'd be x plus 2. So that's where our x plus 2 in parentheses came from. And then x being a 0, that just means that our factor is x. And just like the last time, you can square either one of them. I could square the second, or I could square the first. I could square the binomial, or I could square the x. And either one of these, if I multiplied it out, which it said do not do, but if I multiplied either one of these out, it would fit this rule for B. All right, hopefully this helped. The factor theorem and the remainder theorem are both very important, and they can sometimes prevent you from doing a lot of division unnecessarily. So good luck going forward, and again, I hope this helped.